For topic two, we're going to look at converting rates. Okay, so let's do a quick reminder of what a rate is. So we talked about a rate at the beginning of the chapter. Okay, so first we had this idea of a ratio. A ratio is a comparison of two quantities. So anytime you're comparing two things, that is a ratio. But then a rate is a special type of ratio where you're comparing two quantities that happen to have different units. Okay. So rates, again, are special ratios where you're comparing two quantities that have different units, and that's going to be kind of a big deal for us, okay? So essentially what we're doing is we're converting a rate that has two units to begin with into a different rate that has potentially two different units there too. So we really need to use dimensional analysis, and dimensional analysis is going to be, it's going to be pretty nice. We already get the gist of it. We're just going to have kind of this extra layer in it, okay? So again, we definitely use dimensional analysis, and please note the final answers should include two different units because when you're dealing with rates, rates have two different units and both units matter, okay? So example 5 says convert each rate, can include correct units with each answer, round to the nearest hundredth is needed. So this time we're going to round 2 decimal places if necessary, okay? So first up, we have 70 miles per hour, and we want to convert it to kilometers per hour. So we're really only doing one conversion here. We're really just converting miles to kilometers because the second unit, hours, is the same, okay? But the way we would start this is we would write out our first unit, so 70, or our first rate, 70 miles per hour, but we would write it as a fraction. So 70 miles to 1 hour. And I need to convert that to something that is kilometers per hour. So the first unit right here, this is going to be in the top, and the second unit is going to be in the bottom. Well, we already have hours in the denominator, so we don't really have to do anything with that. We just essentially need to convert miles to kilometers. So we need any unit mile to disappear, and we need to find a way to build in a kilometer. So we multiply by a unit fraction. We've done this loads of times. So we're going to multiply by a unit fraction that relates miles and kilometers. Okay, so let's go back to our conversion sheet. We've already done miles and kilometers once, but in case you forgot, let's go to our conversion sheet. So miles are US, kilometers are definitely metric. So we're going to go to the US metric part of the table, and it's length that we're looking at. And we have that 1 kilometer is approximately 0.62 miles. Okay, so we need that. 1 kilometer is approximately 0.62 miles. Okay. So 1 kilometer, approximately 0.62 miles. And so I'm going to build a unit fraction based on that information. And I need miles to cancel, and I need kilometers to end up in my numerator. So I'm going to go 1 kilometer over 0.62 miles. And then what happens is the miles cancel, and I'm left with kilometers in my numerator, which is exactly what we want. So we've got the first unit in the numerator and the second unit in the denominator. And now we just need to clean it up and do some division. So for the numerator, I have 70 times 1 kilometers. For the denominator, I have 1 times 0.62 hours. So that's just going to be 0.62 hours. And we're for sure going to let the calculator do the side work for us. So we need to do 70 divided by 0.62. So 70 divided by 0.62, and the directions here told us to round to the nearest hundredth, so 2 decimal places this time. So we've got 112.903, so we're going to put that on the next sheet, and then we'll do our rounding. Was that 112? I need to remind myself. 112.903, yes. So we get right here approximately 112.903. My dog is starting to bark. I'm sorry, she hears people outside. Okay, so a hundredth is right here. That's 2 decimal places out. 1 digit to the right is a 0 or is a 3. So that tells me to round down. That means the 0 can stay the same, and then I just chop the 3 off. So this is 112.90, but we don't generally need the zeros at the end of a decimal. So I'm going to say we have 112.9 kilometers. Sorry. Okay, she went outside. Sorry. She was asleep, and there were some people that came to visit my neighbor, and my doors are wide open, so she heard them talking, and it startled her. I think she'll hopefully. She's so darn cute. I can't even be upset with her. Okay, so we end up getting 112.9 kilometers per hour. So if you were driving at a rate of 70 miles per hour, that would be equivalent to driving at a rate of 112.9 kilometers per hour. Okay, now for part B, we have 250 pints per minute, and we want to convert that to gallons per hour. So this could be a couple of things. Like I'm imagining you have some machine that can fill pint cups and that can fill 250 pint cups per minute. What would that be in gallons per hour? So that would be some kind of scenario that I could envision. But we're going to start with 250. Boy, she is still going to town. So 250 pints in a single minute, okay? But our conversion that we want to convert to, we need to convert pints to gallons and minutes to hours. So I need gallons in the top, hours in the bottom. This is going to be a big conversion. We're going to have several unit fractions here. So we first need to decide, are we going to deal with pints and gallons or are we going to deal with minutes and hours? And it does not matter. So let's say we deal with pints and gallons first, okay? So I need to multiply first by a unit fraction that relates pints to quarts, okay? And I happen to know there are 2 pints to 1 quart. I then need to multiply by a unit fraction that relates quarts to gallons. And I happen to know there are 4 quarts to 1 gallon. Now, if you don't remember that, that is absolutely fine. You can use your conversion sheet, okay? Now I need to address minutes and hours. So I need to convert minutes to hours. And this is not a conversion. I don't remember if this is on your conversion sheet, but this is just basic time. We know how time works. And just know that there are 60 minutes in 1 hour. So when I multiply by a unit fraction relating minutes and hours, this time I want minutes in the numerator so they cancel. Okay, so I want 60 minutes over 1 hour. And let's see what this gives us, okay? So we want everything to cancel, but hours in the denominator and gallons in the numerator. So hopefully everything else cancels. So let's see. Well, pints cancel, that's good. Quarts cancel, that's good. Minutes cancel, that is good. And that left us with gallons in the numerator, hours in the denominator, which is exactly what we want. Okay, so let's clean it up a little bit. So my numerator is going to be 250 times 1 times 1 times 60. Well, 250 times 1 times 1 is just 250. And then times 60, and remember the unit is gallons. In my denominator, I get 1 times 2, which is just 2, and then times 4 times 1, which is just 4, and that's going to be hours. And so we get 250 times 60 in the numerator, and then we get 2 times 4 in the denominator. So I'm going to do some side work just on my personal calculator here instead of switching back and forth a whole bunch. So we know the denominator is just 8. 2 times 4 is 8. That's not bad. But then I'm here to tell you that 250 times 60 is 15,000. All right, so essentially, if we're pumping out 250 pints a minute, that is equal to 15,000 gallons in 8 hours. But what is that in just gallons per hour? Okay, so let's see here. We want to go to the calculator, and we have 15,000 divided by 8. So we get 15,000 divided by 8 is 1,875. So this ends up being, finally, after a good bit of work, I totally forgot the number already. Was it 1875? It was 1875. So 1875, so 1,875 gallons per 1 hour. And that would be our final answer. So we went, just imagine something that cranks out some kind of liquid, 250 pints for per minute. And what did that be in gallons per hour? It is 1,875 gallons in 1 hour. So that is converting rates, okay? Part A, not too bad. We were really just doing one conversion. Part B was a true rate conversion where you're converting 2 measures at the same time, okay?